Hi, I'm John Rowland with Highland Park Lapidary, and what I'm going to do for you today is I'm going to give you a feature by feature comparison between a Highland Park 16-inch slab saw and a Covington 16-inch slab saw. I'll start first with the sheet metal and enclosure. The Highland Park has basically 1/8-inch plate, and we have a full steel hood. And basically the spray guard, the way it comes up, it doesn't stop you from getting to the top of your blade. Feed screw comes through the front. The legs, we have casters on the legs down here. 2 locking, 2 rolling. So basically it's a pretty heavy duty assembly, all full welded. 2-inch drain cap, because when you go to take the muck out of the saw, a little tiny drain cap, the stuff just won't come out. Anybody who's tried that will know that. Full belt guard on the side. This one screw opens and the belt guard hinges open to access your pulleys and your speed change. This is a 3-speed unit. So by just moving the pulley over to the different size, you get a different feed rate from slow to fast. So that's pretty much it on the sheet metal, the general sheet metal assembly here. And then I'll walk over here to the Covington and compare it. The Covington sheet metal is about, looks close to a 1/16 of an inch, so it's about half the thickness of the Highland Park. Basically the hood doesn't open the full length, and it's got this weird window in the top. I don't know whether they've changed this in subsequent versions, but they pretty much look the same now. The legs are made out of bent sheet metal, no casters. The legs actually are pretty easy to bend. The spray guard actually comes down and stops you from getting to the top of your blade. So you can't get as big of a rock as you could. And then my favorite part is the drain, which is a little, I think it's a 3/8 or 1/2 inch NPT, but I can't imagine how you get really anything out of that. The motor size on the Highland Park is a 3/4 horsepower. The motor size on the Covington is 1/2. Now let's talk about carriage assembly and how the feed system works. Basically on the Covington, there is a feed motor mounted on the back, and it runs this feed screw right here. Their feed dogs is a little alligator clamp thing that goes on here and then pushes the vise forward. If you look at the way the rails are set up, this is basically like a friction slide on the left that goes on a round rail, and the right side just is sitting on top of a piece of angle iron. Now, the main disadvantage of this particular kind of setup is that there's a lot of movement, and you can even, matter of fact, you can even see that when you're moving this stuff, you can flex this, because this is only 1/8-inch angle iron. In a carriage design, rigidity is everything. So if we go over and we look at the Highland Park, we have 2 tubular square rails, roller bearings that roll on those rails with a underside adjustment. This saw is pretty dirty. We've been cutting agate here and didn't want to stop. But if I grab the back of the vise on this and try and move it, nothing moves. It's just completely solid. If I try and push it side to side, nothing moves. There's no angular movement like this. So if I go back over to the Covington and I look at this and I go, I'm going to go up and down, I got at least 3/8 of an inch of movement. That means when that saw comes into the blade, this is going to start climbing up like this, and oh, I'm looking at the side-to-side movement. I got a tremendous amount of side-to-side movement. Now there's these little adjustments here, but that really doesn't take all of the slop out. Fundamentally, if you look at crossfeed, if you have a single crossfeed rail and a single crossfeed screw, you're not going to be able to keep the whole thing from moving. So we go back over to the Highland Park and look at the crossfeed. We have 2 crossfeed rails, precision ground. a crossfeed screw in the middle, which means the force applied is going to be straight. It's not going to try and twist it at all. And then we have an adjustment. There's 2 nuts on the left side to this collar, and that adjustment allows us to control the backlash on it, so you don't get any side-to-side slop. If we look at this setup, the crossfeed nut is actually just threaded into this casting here. So if you look at your side-to-side slop here, the only way you can stop that is by adjusting this collar. But if your collar's adjusted and your threads are getting worn here, then you look at this movement, and this isn't that old of a saw, and it's really worn, which means that can move side to side, and you're effectively gonna allow your slab that you're cutting to move side to side, or your specimen. Let's see, what else to show you? I think those are primary differences. Oh, the crossfeed. This one, because you don't have any crossfeed nuts to adjust here, as you're cutting, if you have it set up here and the saw is moving through, that handle can actually start moving on its own. You know, it's not gonna stay still, particularly as it gets more sloppy here. And you can try and adjust that, but 2 crossfeed rails versus 1 isn't the same. Then, the best news is the better saw can be had for a lower price.